Welcome to my channel. Today, this is the second part. I will discuss about the periodic table part number 2. Here, this is the complete table of modern periodic table on the basis of Henry Moseley. First of all, you have to understand the S block, D block and P block. Again there is a P block. That means there is under S block there is two groups. In previous video I already told that periodic table contains 7 period and 18 groups. Here is 1 to 18. This is a group number, and 1 to 7 this is period number. So we have to first find out the S block element. S block element, here 1A, group 1A contain hydrogen, lithium, sodium, potassium, rubidium and cesium and francium. And group 2A contain beryllium, magnesium, calcium, strontium, barium and radium. From the right hand side, that means right side of the periodic table, it contains P block element, boron, aluminium, gallium, yttrium. Like this way, carbon, silicon, here nitrogen, phosphorus. Actually, this periodic table is built up on the basis of atomic number. Here is 1, here is 2, here is 3, 4, 5, 6, 7. The gap is placed intentionally. This is not a wrong table that like that there is unfortunately gap is there. This is not. This is an intentionally gap. Actually, Mendeleev in that time he assumed that in later after 100 or 200 years after, actually from his time, definitely new element discovered and those new element can be placed within this gap. But in later case, the table is formed on the basis of energy level. The energy level, why the gap is there, I will be discussed in later video. But in this video, I want to discuss some salient feature of this table. Some salient feature is like that. You see that this group 1 element, that is hydrogen, lithium, sodium and potassium, all those are kind of same nature. Why it is same nature? Because in their outermost cell, the configuration is like that. This is 1, this is 2, 1, this is 2, 8, 1 and this is 2, 8, 8, 1. In like that way, this also can be formed by 2, 8, 18, 1 like this one. Here, the outermost cell contain 1 electron configuration. That means they are all functions like that, they all want to remove 1 electron from their outermost cell to form positively charged the single cation. That's why their nature is similar. And if we see group 7A, we can't take the all example in a single video. That's why we take only two group, that is 1A and 7A. In 7A, this is 2, 7. Atomic number is 9, that's why 2, 7. Okay. And this is 2, 8, 7. Like that way, here also the outermost cell configuration is 7, 7. And also here also this 7 you can place. So, these elements from this group represent that they are always try to gain electron to form a negatively charged ion. That means all the group members are same characteristics, and here also all the group members same characteristics. That means periodic table is too much logical. As you think like that way, those are elements which represents the group, like those are the like royal family, royal members of the family. Okay. So that's why this is a salient feature, and we can track a element very easily. Like that way, if one atom try to give up electron, that means it nature of metal, it's some nature of metal. That means all those are metals. Okay. And if an atom try to gain electron, it wants to negatively charge, form negative charge ion. That means those are non-metal. So we can track an element from the periodic table, and we can say either it is metal or either it is non-metal. This is the salient feature. You can take a metal like that, you can take an element like that, magnesium. Is it metal? Is it metal? We can track easily like this way. Magnesium, that means 12. Okay, 12 is 2, 8, 2. That means it's try to give up electron. That's why it's metal. So we can easily say that from left side of the table, from the left side of the table, if we gradually go to the right side, the metal characteristics gradually decreases and non-metal characteristics gradually increases. So we can easily say that the left side of a periodic table all are metallic character, and right side of the periodic table are non-metallic character. Now, how we can say an element like that with the which place or from the place we can say that their atomic configuration. How? First of all, we have to find out the group number and the period number. Suppose take calcium. Calcium from the periodic table we find out that calcium period number, that is period number of calcium, period is 4. Okay, calcium is 4 period, and group is 2. Group is 2. That means calcium has 4 number of cell. You can track it like that way. Suppose calcium 4. 4. Okay. Here cell is 4, so you can place like this way. A space is not there, that's why I am trying to draw like that way. So 2, second cell also contain 8, and last cell is, since the group number is 2, that means last cell content must be 2. So it configuration like that way, 2, 8, 8, 2. Okay, here is 4 cell. Okay, 4 cell means 2, 8, 8, 2. 4 cell, and okay, there is a wrong. I should correct like this way. Calcium should be like that way. There is 2, 8, 8, and let's 2. Okay, this is not interested in any mistake. Actually, the calcium structure is so 2, 8, 8, 2. That means if the cell is 4, cell number is 1, 2, 3, 4. So period should be 4, and group number represent, those group number is the valency of this element. Like this way we can track element from the atomic structure or atomic configuration. We can say which group and which period, and also simultaneously we can say if an element present in this group or in this period, what will be its atomic structure. Okay, thank you for watching my video. Next day I will discuss more about the periodic table. Okay, thank you. Please subscribe my channel. Okay, that's all.